neurolinguistics, which is a field studied in psycholinguistics. So the contents of today's lecture are: first, what is neurolinguistics? This might be a new term to you. This might be your first time to hear of this term, neurolinguistics. What does it mean? The second element for today is: how can aphasia tell us about the representation of language in the brain? We're going to look at the meaning of aphasia in a moment. The third element for today's lecture is language lateralization. We're going to see what do we mean by language lateralization and how is language lateralized. So the first element for today is neurolinguistics. What does it mean? The definition of neurolinguistics is the study of the representation of language in the brain. So we have an extra article. Alright, so it is the study of the representation of language in the brain. How is language represented in the brain? In this slide we are going to look at two things. The first is, how does the brain look like? This is necessary for you in order to understand how is language represented in the brain. It is necessary to see how does the brain look like? How does it look like? The brain is composed of two hemispheres. What we mean by hemisphere is, for example, if you have a bowl and have it in two parts, we have a hemisphere on the right and a hemisphere on the left. The Earth has two hemispheres: the north hemisphere and the south hemisphere. Okay, sphere means bowl, hemi means half. So half the brain can be divided into two parts. There's the left hemisphere, the left side of the body, of the brain, sorry, the left side of the brain, and the right side of the brain, which is called the right hemisphere. So the brain has two parts. It has two hemispheres, two halves, the right and the left. Okay? So the left side has the ability, or gives you the ability, for reasoning, for analytical thinking, for logic, for language, facts, numbers, sequence, details, and details. Okay, so this is the job, this is the responsibility of the left side of the brain. Now let's look at the right side of the brain. It deals with sensations, with fear, with joy, with happiness. It deals with sensation. It deals with intuitive, and it deals with experience, with music, with feelings, with analogy, with randomness, and with big images. The big image of something that is represented in the right side of the brain. As we can see, language is, for the majority of people, of course we are going to take this in detail in the last part of the lecture, which is language lateralization. For the majority of people, language is in the left side. But of course there are people who have language in their right side of the body, and we have people who have language in between, both in the left hemisphere and the right hemisphere. We're going to take this in detail in the last part of the lecture. But in this part, it is enough for us to know that the majority of people, the vast majority of people, have their language in the left hemisphere, on the left side, on the left half of the brain. Okay? So this is neurolinguistics. If you have been asked what is neurolinguistics, it is the study of the representation of language in the brain. Okay? Now, since we have seen that language is somewhere in our left side of the brain, it might be interesting to ask, what happens if there is a damage to this part where language is, can language be affected? What happens to language if there is a damage in the left hemisphere of the brain where language is? If you can see, language is here, language is in the left hemisphere. What happens if there is a damage on the side of brain where language is based? So if there is a damage to this area, the damage can lead to aphasia. What we mean by aphasia? What is the definition of aphasia? It is language impairment which is caused by brain injury. What we mean by impairment is deterioration, is lack of ability. Now most of you speak fluently. What happens if you had a damage on your left side of the brain? Is this going to affect your ability to speak or not? So the damage to the left side of the brain, let it be a car accident or a stroke, which is called in Arabic تجلط الدم. If this happened, does this lead to a language impairment, to difficulties in speaking, to difficulties in understanding speech? Of course, if there is a damage to the left side of the brain, for the majority of people, this damage can lead to aphasia, which is language impairment. Okay, there are two types of aphasia, depending on the damaged area of the brain. So this is the left side. What you see in the slide is the left side of the brain. So this is the left side. As we have said earlier, there are two sides of the brain, the right and the left. This is the left one. Each hemisphere of the brain is composed of areas. For example, the frontal lobe, which we can see here, the frontal lobe, the temporal lobe, the back side, and the occipital lobe, and the parietal lobe. Okay? These are parts of the left hemisphere of the brain. Scientists have been noticing that people who have a damage to this area, Broca's, which is called Broca's area, it is located in the frontal lobe of the left hemisphere of the brain. Okay? It is located in front of the left side of the brain. It is called Broca's area. People, psycholinguists or neurolinguists who have been observing the patients, the people who have received an injury on this part of the brain, which is called Broca's, they have noticed that they have difficulty in production, in language production. Whenever they try to speak, they have difficulties. They are not able to speak fluently. People who have received a damage in this area. In the past, they used to be perfect. After the damage, they started to have difficulties in production, in speaking. Neurolinguists as well have noticed that people who have received a damage in the Wernicke's area, this area, the greenish area, or the dark blue, I'm not able to tell what color is this. Perhaps some people refer to it as turquoise. So this part, which is called Wernicke, people who have received a damage on this side of the brain, on this area of the brain, linguists have noticed that they have a problem with understanding speech. They can speak fluently. They speak meaningless sentences. If you know someone who is old and he has the what is called al-kharaf in Arabic, you'll notice that they speak fluently. They don't have any problem with their speaking, but they are not. They have a problem with delivering their message. They are not able to express their ideas clearly. They are able to speak, but they have a problem with clarity of speech. with perception. Okay, so there are two. For the time being, it is interesting for us to see how does the brain look like. It has two sides, two hemispheres, the left and the right. Language for the majority of people is on the left side. There are two areas which can influence your speech if injured. The first one is Broca's area. The second is Wernicke's area. Okay. Now let's look at the definition of these two kinds of aphasia, Broca's and Wernicke's. Broca's aphasia is known as non-fluent aphasia. Why is it called non-fluent? Because people have a problem with production. If you have a difficulty in remembering which one is which, if you have a problem with remembering whether Broca's or Wernicke's aphasia is the one which influences production, I will give you a mnemonic. I will give you something which helps you to remember. Broca starts with B. Production, Broca and production. Two similar letters, B and P. Broca's area is responsible for production. So people who have a damage in Broca's area have a problem in production, have a problem in speaking. They cannot speak fluently. Wernicke, of course, Broca is in front. B is one of the front letters, A, B, C. So B is in the front. So Broca's area is in the front. B, front. W is back. So Wernicke's is in the back. The temporal lobe, which is the back side of the left hemisphere. So W is one of the last letters in the English alphabet. W, Wernicke. So and B is one of the first letters in the English alphabet. So the first is in the front. So Broca, B starts with B, production, BP, and the letter B is in the front. So Broca's area is in the front, the Wernicke's area is in the back, the temporal lobe. I hope this helps you remember which one is responsible for production and which one is responsible for perception. So Broca's aphasia is also known as non-fluent aphasia. It is characterized by halting, by continuous pauses, by effortful speech, and it is associated with damage involving Broca's area, which is in the frontal lobe of the left hemisphere. The second type of aphasia is Wernicke's aphasia, which is known as fluent aphasia. Fluent because they don't have any problem with speaking. They can speak, they can produce language. They are fluent. They can speak without any pauses, without any difficulty to speak. But the problem is they are providing us with meaningless strings, meaningless sentences. And this type of aphasia is caused by a damage in the Wernicke's area, which is in the temporal lobe, which is in the back of the brain, in the back side of the left side of the brain. Now we are going to look at language lateralization. So the brain controls the body in a contralateral way. What we mean by this is, if you have a look at the picture we have here, the left hemisphere controls the right eye. The right hemisphere controls the left eye. So the left hemisphere of the brain controls the right side of the body. So if you want to move your right hand, the side which controls the movement is the left side. If you want to move the left hand, the side which controls the left hand's movement is the right side. Some people who have a problem in movement. Some people who have a problem with moving, for example, their left their left hand and their left leg. Probably this is because they have a problem in the right side, etc. And the vice versa. So the left hemisphere of the brain controls the right side of the body and vice versa. So how is this related to our language ability? It can influence handedness. What we mean by handedness is which hand do you use in writing. If language is for the majority of people, they have their language on their left side. That's why the majority of people use the right hand to write. So right-handers, which are the majority of people, have their language on the left or the right side of the brain. That's why they are right-handers, because language is in their left, or is in their left side of the brain, in their left hemisphere of the brain. Some people, like me, I'm left-handed, so language is in my right side of the brain. So for some people, language is in the right side of the brain, and they are called left-handers. They are not able to write with their right hand. They write with their left hand, because language is in the right side of the body. For very few people, language is represented in both sides, the left and the right side of the body, and for this very limited number of people, they are able to use both hands in writing. Okay, they are able to use both hands in writing. What interests us here is the fact that the brain's control of the body is contralateral. The left side of the brain controls the right side of the body, and vice versa. And how does this influence our language abilities? One thing is handedness. Some people use their left hand to write, and some people use their right hand to write. Why? Why is this? Of course it is because the representation of language. Where is language based in your brain? Is it on the left side or the right side? Okay, this brings us to the end of today's lecture. I hope you have enjoyed it, and thanks very much.